Welcome to everyone. Today we are going to see the topic called Vernam Cipher. So Vernam Cipher is one of the topic in cryptography and network security. The concept behind this Vernam Cipher is that bitwise XOR operations. We know that we have many operations are there, AND operation, OR operation, so NAND operation, OR operations, same as XOR operations. Here the concept of using Vernam cipher is XOR operation, that is bitwise XOR operation for both encryption and decryption technique. It gives more perfect secrecy for the particular process. So that is one of the advantage of this using this particular cipher. So it is mainly used in current era with the theoretical foundation of cryptography. So that is one of the important thing. So and also it gives it does not depend on the security. The most of the security features are dependent on complexity, but this algorithm does not depend on the complexity. It gives more computational thing. So what is the concept behind this Vernam cipher? So here the first constraint is the Vernam cipher is plain text and key value will be equal, should be equal. If it is not, once we equalize this both and we start our process. If it is not, the process is not done, not to be done. That is an important constraint of this particular cipher technique. So the key value and plain text will be equal. Then we start our XOR operations. Once the XOR operation is completed, we get a one outcome that is called cipher text. So plain text and key value with the same length perform XOR operation. We get one value that is called cipher text. That will be reversed for possible also in Vernam cipher. So what is the concept is XOR bitwise already told that bitwise XOR operation that is belongs to the truth table. The both the bit are equal, it gives 0. The different bits are different, it gives 1. So that is the origin of this XOR cipher truth table that will apply in our concept. We have two process, one is encryption process and one is a decryption process. Encryption process convert plain text into binary. The next step, convert key into binary. Next, perform XOR operation with the help of same plain text and key value. We get the ciphertext. We using the formula ciphertext equal plain text XOR of key value. So this is come under encryption process. The same way decryption process, ciphertext is XORed with the key value with both same length and we get the plain text. The formula for an decryption process is plain text equal to ciphertext XOR of key value. You see one example. So we have plain text hello and key value is XMCKL. So first the plain text is converted into ASCII value because we can convert it into zeros and ones for use performing the bitwise operator. For that first we convert it into ASCII with a decimal value with the help of ASCII value. So that is H is the value of 72. So we converted 72 into bitwise or bit binary value. Again E means 69. The 69 means again converted into binary. Same way L and O. So the first plain text will be converted. After that key will be converted. Now we have a key binary value of key and binary value of plain text. Now we can apply the XOR operation. So with the help of this truth table, so H binary and X binary will be converted into one gives one value. Same way EM, LC, LK, OL. So we have some outcome is we have some binary value. We will convert that binary value with the help of decimal. We get one value that is the cipher text of this particular plain text and key value. So now this for this example we get the value is sequence of XOR output is 16 8 15 7 3. Again we can convert it into decimal with the help of ASCII value. Then we get one again we will get the outcome. The same way we'll repeat for decryption process. So this is operations of Vernam cipher. So what is the main advantages of this Vernam cipher? The advantages before that advantage for it gives more perfect secrecy. How it gives a more perfect secrecy? The key length must be same. That is one of the thing. The length will be equal. Another thing, the key must be used only once, and also it's a random one. it gives more security with the help of these things. So that gives a more perfect secrecy for this algorithm. So another one, we can use only XOR operation with the help of truth table. So that is a traditional model. So it gives you a simple truth table. With the help of a simple truth table, we implement this encryption decryption process. So it will be simple and easy to implement. And also there is a no frequency or pattern analysis possible, because we can use only the key value will be used only once, and also it will be a random. So there is a no way of frequency or pattern analysis. And finally, we get exact output for encryption and decryption. So we give mathematically proven it should be secure with the help of the simple logic. And here are some limitations. Yes, here the key generation is difficult because we have only few things, unique things, so the key value is difficult. And also the secure key distribution is challenging because we have limited number of words and limited number of things, so it's a challenging to everyone. We can store the key value each and every time, that's also it's require a storage, so it's also one of the thing for limitations. Well, come from the security, it's never used only, key is used only once, so never reused. So that is one of the important things. So you can't get the key value easily. So the hackers, we have a challenges to break the code. So that is one other thing. Another one is that it is a key value is not reused. That is another one advantages, and for security purpose. So where it will be used, it mainly used for military and diplomatic communications. So and also we can use high government of communication channels. So wherever we go for a more communications and more secure purpose, there we use the Vernam cipher. So that is a more basic for modern encryption technique. So these are the few applications of this Vernam cipher. Thank you. Thanks for your patient timing. Thank you.